We've always been taught that some things in science are just set in stone, right? These fundamental numbers that are baked into the very fabric of reality. But what if they're not? That's the huge question we're tackling today. Could the basic rules of our universe actually be evolving?
And look, this isn't just some abstract thought experiment. This idea challenges everything we think we know about the cosmos. I mean, if the very bedrock of physics is shifting under our feet, well, what does that mean for everything?
Okay, so for a long, long time, we've thought of the universe as having this perfect rule book. You could even call them the 4 pillars of reality. These are the constants that hold it all together, from the tiniest particles to giant galaxies. Let's break them down. All right, first up, the big one, c, the speed of light. Now, this isn't just how fast light travels, it's the absolute, unbreakable speed limit for anything in the universe. It's what makes sure cause comes before effect. And yeah, it's the c in Einstein's famous E equals mc squared, the equation that links energy and matter into one beautiful package. And this isn't just some abstract cosmic rule either. Think about the GPS on your phone. It works because it assumes c is perfectly, absolutely constant. If that number wobbled even a tiny bit, your GPS would think you're miles away from where you actually are. We literally bet on its stability every single day. Next up, we've got big G, the gravitational constant. This one isn't about speed, it's all about strength. It's the number that sets the volume for gravity, that universal pull that keeps your feet on the ground, the Earth orbiting the sun, and entire galaxies from flying apart. And you really, really don't want this number to change. Seriously. If G got weaker by just 1%, the sun's grip on us would loosen, and the Earth would start to slowly drift away. Just floating off into the cold, empty darkness of space. No thanks. Okay, let's zoom way in, down to the quantum level. Here, the boss is Planck's constant, or h. It's the rule that says energy isn't smooth and continuous, like a ramp. Nope, it comes in tiny, distinct little packets, called quanta. Think of it like this. Reality isn't a painting, it's a pixelated image. H is the size of a single one of those pixels. And again, this is in your pocket right now. Every single pixel on your phone screen is glowing because of H. The LEDs are spitting out light in those exact, precise energy packets. If H were different, that precision would go out the window, and your beautiful, sharp screen would just blur into a meaningless smear of light. And for our last pillar, we have the most mysterious of them all, alpha, the fine structure constant. This one's weird. It's just a pure number, about 1/137. No units, no dimensions, it's just a ratio. But it's arguably the most important one, because it sets the strength of electromagnetism. That's the force that holds atoms together. It's the reason chemistry works and the reason we're here at all. I mean, just look at how ridiculously fine-tuned this is. If you change alpha by just 4%, the electromagnetic force goes haywire. Stable atoms become impossible. And if you don't have atoms, you don't have chemistry, you don't have stars, you don't have DNA, you don't have us. It's that precise. So, there you have it, 4 pillars of reality, seemingly solid as a rock. But what if they're not? For a while now, scientists have been hearing these whispers, little hints from the farthest reaches of the cosmos that maybe, just maybe, there are cracks starting to show in these foundations. And this really gets to the heart of it. Which view of the universe is right? Is it this perfect clockwork machine where the rules were set in stone at the very beginning and never change? Or is it something more organic? A dynamic cosmos where the laws themselves can evolve, like they were scribbled in pencil, not etched in stone. And this isn't just some wacky idea from the fringes. Some of our biggest theories, like string theory, actually hint that these constants could change over billions of years. Other models that try to solve puzzles with the Big Bang even suggest the speed of light used to be different. So the theoretical door is definitely open. Okay, so theory says it's possible, but is there any evidence? This is where things get really interesting. It's time to go from theory to experiment and start hunting for actual cosmic clues. Our ability to measure these things has gotten ridiculously good over the years. We went from using the moons of Jupiter in the 1600s to today, where we have atomic clocks that are mind-bogglingly precise. But the real key, the way we can look back in time, is by studying the light from ancient quasars. That light is like a time capsule from billions of years ago. And it's in that ancient light that has been traveling across the universe for maybe 12 billion years, that we found our most tantalizing clue yet. It suggests that the laws of physics might not be the same everywhere you look. What they found is what scientists call a 4 sigma signal. Now, sigma is just a way of measuring how confident you are that what you're seeing isn't just random luck. 1 or 2 sigma, could be noise. But 4 sigma? That means there's less than a 1 in 15,000 chance it's a fluke. It's a really strong hint that alpha, the fine structure constant, is a tiny bit different over there than it is over here. But here's the catch. The evidence is all over the place. On one hand, you have this crazy signal from distant quasars that says things are changing, but on the other hand, our super precise atomic clocks right here on Earth show nothing, zero change. Plus, there's this amazing natural nuclear reactor in Africa that was running 2 billion years ago, and it also suggests the constants were the same back then. So the scientific jury is very much still out.
So, where does that leave us? Let's talk about what all this means. What if the rules really can be rewritten? What would that do to our picture of the universe?
Oh, the stakes are just massive. Our whole story of the Big Bang, we might have to tear it up and start over. The ultimate fate of the universe, how it all ends, suddenly we wouldn't have a clue. It could even explain why our universe seems so perfectly tuned for life without needing to imagine a bazillion other universes in a multiverse. It's a game changer.
It really comes down to this. A universe with fixed constants is like a clockwork machine. It has a predictable fate. But a universe with evolving constants? That's more like a living thing, something that adapts and changes, with a future that's still being written. So, the question we're left with is a big one. Is the book of our universe already finished? Or are we living in a chapter that's still being written right now as we speak? The hunt for that answer? Well, that's one of the most exciting things happening in science today.